Hello everyone, Mr. Hisner here, and today we're going to be starting to look at trigonometry. And trigonometry is actually the study of triangle measurements. Now hopefully you watched the video above where we looked at sort of the history of trigonometry, or just touched on it just a very little bit. It dates back more than 3,000 years, and is really largely the base of all things in modern mathematics. So yeah, it's by far the most interesting part of geometry. So hopefully you guys will share that thought with me as we move forward. So we have things that are called trigonometric ratios. Nice. My thing's not connected. So we have trigonometric ratios. So what I'm going to do here is I'm going to draw a triangle, try to do like a right triangle. Okay. Just pretend this is a right triangle, at least in your heart. So right triangle. So this is triangle ABC. I don't know what's up there. Let's do A, B, C. So this would be like triangle A, B, C. And then we would have these sides. I'm just going to call them little a will be across from the angle A, little b would be across from big B, and then little c would be across from, notice how like I'm just naming this whole side little c. So just using some lowercase letters. That way we can kind of keep our wits about us. So what is trigonometry? Well, we have these three ratios. We have sine, not sin. We have cosine. And then we have tangent. So we have these three trigonometric functions, as they're called. And so sine is the ratio of the opposite and hypotenuse, of the opposite and the hypotenuse. So for example, if we were going to look at angle A. So let's say angle A, let's just call angle A alpha. So if we're going to look at angle A, the opposite side, the opposite would be the one that's across from angle A. So that would be the ratio of the opposite. So that would be, it would look like sine of angle A would be the opposite, which would be this side, little a. And the hypotenuse, which is always across from this right angle, which is C. And so, for example, we can even look at sine B. So the opposite. So if we're going to look at the sine of angle B, if we're going to look at the sine of angle B, this would be the opposite. Well, that's going to be little b. It's the one that's right across from angle B, and the hypotenuse stays the same. It would still be C. Oh, my bad. There we go. Okay, let's look. So the cosine is the ratio of the adjacent. Cosine is the ratio of the adjacent. Let me clear this up in here. Cosine, this is the ratio of the adjacent and the hypotenuse, and the hypotenuse. So here we go. Let's look at what this cosine of angle A would be. The adjacent. Okay, so here's angle A. Adjacent means right beside. So if the opposite is across, the hypotenuse is across from the right angle. The adjacent is right beside. So this would be little b over the hypotenuse, which would be C. This would be little b over C. Now let's say if we wanted to find the cosine of angle B. Well, this would be the adjacent side would be right beside it here, right beside it. So that would be little a. And the hypotenuse again would be C. Hypotenuse never changes. Now let's look at what the tangent is. The tangent is the opposite over adjacent. So this is the ratio of the opposite side and the adjacent side. So let's look again. Let's look at the tangent of angle A. So the opposite side, of course, will be angle A, and then the adjacent side will be B. So this is going to be A over B. And then the tangent of angle B, that would be the opposite, would be little b. And then the adjacent is the side beside it, is A. So this is how we set up our trigonometric functions. My true apologies. This one's going to run long. I'm going to just do an example here for you. So we have this, the way that this sets up, we have our sine of our angle. Let's just call it the sine of the angle, whatever it is. Theta is opposite over hypotenuse. We have cosine, which is adjacent over hypotenuse. That's a J. And then our tangent, this is of theta, right? Whatever the angle is. Theta is what we call angles we don't know. Let's just kind of move this over. So we have tangent. Let me move it down, actually. So the tangent is, of course, opposite over adjacent. That's a J, ADJ. So for us, if we want to look at a triangle, let's say we have this here, triangle here. And we want to know what is the sine. Let's do A, B, C, 12, 5, 13. This is a right angle. Let's say we want the sine of angle A. Well, the sine of angle A, the sine is the opposite, so that's 5 over the hypotenuse. That's across from the right angle, and that is 13. Let's look at, what if we wanted the cosine of angle A? Well, cosine of angle A, that would be the adjacent. That's the one right beside it. So that would be 12. And the hypotenuse, again, doesn't change. It's still 13. And then finally, we can look at the tangent of angle A. And that is the opposite. So 5 over the adjacent. You know what? Let me get rid of that. Over the adjacent, which we saw was 12. So how could these possibly change? Well, let us look. So let's look at another angle. Let's say angle C. Let's see the sine of angle C. I guess I should be using parens there. The sine of angle C. Parentheses are the word of. So the sine of angle C, this is the opposite. So that's 12ers. And again, the hypotenuse doesn't change. Let's see the cosine of angle C, rather. Let's see the cosine of angle C. This is the adjacent, so that's 5. And the hypotenuse, again, is unchanged. And let's see what the tangent of angle C is. Let's see what the tangent of angle C is. So this is going to be the opposite, 12, over the adjacent, 5. Okay, so that's how we would do very simple trigonometric ratios. Again, our trigonometric ratios are as such. The sine of an angle is the opposite side over the hypotenuse. The cosine of the angle is the adjacent over the hypotenuse. And the tangent of the angle is the opposite over the adjacent. Thanks for watching, guys.